Analysis of the effect of variations in refractivity gradient on line of sight percentage clearance and single knife edge diffraction loss. This article is written by 3 authors. First author Rajuita Ui, Dan. Second author Iniani, Johnson. Last author or Inian Markson. Contribution and originality of the study is that this study is one of very few studies which have investigated the effect of variations in refractivity gradient on line of sight percentage clearance and single knife edge diffraction loss. The ideas presented can easily be used to study the effect of variations in atmospheric parameters on wireless signal quality. In this paper, analysis of the effect of variations in refractivity gradient on line of sight percentage clearance and single knife edge diffraction loss is presented. Relevant, mathematical expressions and approaches for the analyses are presented. Sample path profile data of terrestrial line of sight, LOS, microwave communication links operating at C-band 5.5 GHz frequency and Ku-band 11 GHz frequency with 15 km path length are used in the study to demonstrate the application of the ideas presented in this paper. The results showed that the critical point of minimum loss percentage clearance occurred at a distance of 8.89 km from the transmitter. Based on the results, regression models were derived for relating the refractivity gradient to the effective earth K factor, earth bulge, loss percentage clearance and single knife edge loss percentage clearance. The implication of the result is that, given that for any location the refractivity gradient varies with the primary atmospheric parameters like temperature, pressure and relative humidity, the amount of diffraction loss posed to the signal in the atmosphere will be varying at different rates depending on the prevailing values of the atmospheric parameters upon which refractivity gradient depends. Also, apart from the reference refractivity gradient of 39.25 in units, km, different frequencies will experience different amount of diffraction loss. The specific impact of the refractivity gradient on different frequencies depends on whether the prevailing refractivity gradient is above or below the reference refractivity gradient of 39.25 in units, km. Thanks for watching this video of International Journal of Sustainable Energy and Environmental Research Volume 8 Issue Number 1.